I'll get the audio fixed. Okay. I'm going to drop a link here for everybody. Where are we? Right here. So I am, my body's gone into like spring allergy mode. So my voice is like just hashed. I'd like to apologize in advance. I got, uh, well, so like on the weekend, right? Going into the weekend, it was just so beautiful here, right? And I was thinking maybe this is real spring, not like sucking fake spring. And so it's like throwing the windows open and just forgot. I only started getting allergies about 2 years ago for the first time in my life. Some of you are dealing with that, right? And so I just didn't really think about it. And then last night, about the time I'm heading to bed, it's like I wake up at like 2 in the morning and I cannot breathe, basically. So it was a little bit of a rough night, but so I got to kick back into allergy med mode. That's my share. Miserable. Some of you have been dealing with this like your whole lives with allergies, and I'm so sorry. It's been a late breaking thing for me. Okay, so once again, we're in a mode where your audio is not streaming through. I will maybe get it. I'll maybe get it fixed right after class. How about that? What if I do that? Maybe.
So I have really bad allergies.
But any surprises on the midterm?
You can take 2 allergy pills. That you can't overdose on allergy pills, Professor.
Oh, yeah, I can't hear you. I can't hear your audio. So I wonder. Yeah, you got to type Gunner, Washington, allergies are really bad. Yeah, I did check. Yeah, I'm defaulted to streaming input through my AirPods on Discord. So yes, Derek, I did double check that, but let me also just check the system prefs. All right. Oh, thank you, Walter. I appreciate that, man. And I am set up that way. So here's an interesting question, Walter. When people are talking on, gosh, I just got to fix this. It's just so stupid. It just takes some focus. You know what I mean? It's like a 2-minute fix once you know what you're doing, but it takes like an hour to get context. So, hey, if somebody wants to like stick around right after class and help me, you know, sanity check the settings, that would be great. Let's just do that right after, and then we'll be done and get this thing. I'll write them down, and it'll serve us for the next 4 weeks before the semester ends. Okay, speaking of which, we're going to talk about class diagrams today. We're going to finish talking about class diagrams today, actually. But what I wanted to just drop in, I'm just looking at the schedule real quick, which is today's March 28. Are we in the right? No, sorry, I'm in the wrong. Yeah, today's March 28. So we got this week. Okay, next week it's showing me out of the office, and I am not out of the office. So I got to adjust the schedule to reflect that. Basically, it's going to be kind of like spill over to catch up. So we're still going to have class. And what I'm going to do right now, just to make sure I get this taken care of, is let me just change that right now. I thought I was maybe going to be gone, but topic will be All right, hang on a second. And what is that? All right. If you look on the schedule now, it's going to show next week still having lecture, and it's just identified as whatever we need to catch up on. And so we're just going to kind of, make our march through what UML, and just kind of, and if we get done early with the entire class, finishing everything early is not bad. Oh, I didn't screenshot. Thank you, Walter. Man, I'm so behind the freaking curve. Yeah, hold on. Sorry. It's this thing, man. I didn't sleep well. Let me screen. Thanks for the heads up, man. I appreciate it. Okay. All right. So we're good on screen share now. Yeah. Okay. So let me see. Ripping back through. Yeah. Apologies for the audio. Still, we'll fix it right after class. Thanks, Seth, for the drug report. I got screen sharing going now. Oh, is the Daily Meme Chris Rock and Will Smith? No, but what the crap, dude? Like, yeah, no, that's kind of awkward, It's kind of awkward. You roll on stage, you cold cock, um, Chris Rock, and then you stick around to pick up your Academy Award for Best Actor. It doesn't sell really well, So I don't know, man. No, there's no meme about that. But I did like this. Hang on a second. I did like the memes of the day. The explanation of which units are on which floors is just utterly hilarious. When you consider, from a design perspective, when you consider that you've got these 4 floors, right? There's a parking garage, P for parking, fine. But then you've got 4 floors, and you can put any numbers you want on the units, you know? It's just insane. And given, okay, I am pretty sure that I took that picture myself. You can see the silhouette of the picture taker there. And if I blow that up, doesn't that kind of look like me? Kind of does. Anyway, I'm pretty sure that was me that took that picture. And this one right here, I'm really fascinated by, let me see. No, that's it. No, I'm really fascinated by like weird and pseudo creepy pictures from the 50s that are black and white. And this one just, I don't know, man. You know, that to me is just, that's the 50s. That's the 50s right there. Maybe the 60s. And that kid's probably pounding down a Jolt Cola or something, all going to help him grow up big and strong. Okay. So what's the seeds? What was it? Was it not you? It was me. Oh, that picture's not me. But it was me that took this other picture of the floors. I don't remember where, but I'm pretty sure that was me that took that one. Um, so here's the thing, Mike. I was there in the 60s. I could have been that kid in the 60s. So, all right, let me do this. Let me roll up some. Let's get back to class diagrams. We'll just kind of hit this, get in, get out, and mostly I'm just trying to give you the the gist of things. How far do we get? I know we get distracted every time. Right now, I'm in this sort of like, allergy med recovery mode. You can hear it in my voice. And one of the consequences of that is I'm not super interested in rambling and going long. So we'll see. We'll see what that does. Okay. Oh man. Let's see. Okay, I got slides up. I got OBS. All right. And then again, just remember to drop your stuff on chat. Okay, let me see. That should be still visible to everybody. Right on. Okay. That visibility on the stream is good, right? For the slides. Okay. So by the way, I'm gonna get the midterms graded, get that back to you pretty quick. Just keep plugging away on the golf stuff, and we'll figure out the end of the semester when we get closer. Check my mood for what to do as far as finals and that kind of stuff. I got to throw one of these in. I apologize for the clacky clock sound. Okay. Let's see. You got any? Are there any lingering questions before we sort of bop into this thing? This is. There are 65 slides here, and this is slide number 5. This would be number 6, just FYI. Yeah, Derek, tests will be graded this week. Get that back to you. Turn it around real quick. Um, how far did we get? I'm looking at my spare monitor, which is where this is projecting here in my office. You guys remember? I know we talked about this because we talked at length about coupling and cohesion. And I think we talked about the way in which all these diagrams congealed into UML. I think we talked about that. And I think we talked at length about the idea of the definition we call classes, the definitions of objects we call classes, the instantiations of those classes we call objects. Objects are things that are alive. Classes are things that describe an object so that a system can create one and know what to do. Okay. Here's what we expect to see. The name of the class, the properties, which is the data, and the operations, which is the methods that operate on that data. You got to remember that there didn't previously used to be a world in which data and the methods that operated on that data were encapsulated together. That's the big insight from objects. Okay. And it may seem like a long time ago when that was the case, but it wasn't really. Okay, it was probably 30 years ago, more, when Parnas was writing his stuff. But I'm just saying, in the grand history of the world, it's not a long time, to look back to a point where that was not a thing. And object oriented wasn't really the definitive go to until the last 20 years. So I know it's that's me being the old man. UML uses the term features to refer to all the little things that you see in the diagram. They're each called a feature. So for whatever that's worth, and this is a UML diagram of a class. Okay, and I want to make sure that you just reiterate this, that I really care most about what this diagram makes you think about design. I've said this before, and I just hope you'll listen to it and it'll penetrate into your head. This is not about, most of the things, by the way, the stories that I'm sharing, they're not about, here's the thing you have to know for a stupid test. They're things that, if I were just talking to you and there was just over lunch, there's a thing that I learned and I would want you to know it. These are the things that I'm saying. And one of the things that I want you to understand is that when you get stuck in a situation where you need to design something, look at the diagrams that go along with the thing that you're trying to design. Does that make sense? For example, look at the UML diagrams. I mean that in two ways. One is look broadly at UML diagrams, or look specifically at the UML diagrams that pertain to the thing you're looking at. But looking broadly at UML diagrams and what they enable, the notation exists because there's a thing you can do from a design perspective, and you have to be able to embody it. So if you look at like the Martin Fowler book or some other book on UML and just go, oh, look, there's a name. Guess what? Classes have names. Oh, there's the names of the data. Oh, guess what? Classes and objects have data. These are methods. The methods operate on the data. I can look at a class diagram like this one right up here, like this order right up here, and I can already ask myself questions about, like, does this manifest the right kind of cohesion? Dispatch close. I don't know what these are. There should be some supplemental documentation. That's the other thing I want to say that's really important, is that you can look at these things, but there should be some supplemental other documentation. It tells you what is dispatch, what's it trying to do. There should be a spec on that somewhere. Okay, that it's just writing stuff down, because somebody else is going to have to look at this, maintain it, touch it, understand what the purpose is, and anytime somebody has to reconstruct all of that from scratch just by looking at the code, man, it's taken so freaking long. Some of you have tried to do that, and you know what I'm talking about. But here's a diagram, and this is this guy back here. I'm just kind of bringing it along. Okay, you got that? That's the guy, same guy. Now, and I've said this before, I want to reiterate it. Where do you see this kind of thing? Larger companies with a lot of technical stakeholders. Who's the target? Let me ask you that question. Who's the target, real quick, while we're kind of moving on? Who's the target for a class diagram? And I apologize again that the audio is not being friendly. People who don't know, correct, Landon. Kevin, technical stakeholders, correct. Who else? And who are the technical stakeholders, Kevin, or anybody? I mean, give me some job titles. And Landon, people who don't know is too broad, right? Someone walking down the street is a person who doesn't know, and they're not the audience. Architects, sure. Who else? Coders on the team, right? Software engineers, yeah. QA, the testers. One of the big things that I hope you take away from all this is that you can use any one of these UML diagrams as a way to drive system test design. Okay? Yeah, Landon, people who invest in the project, but don't necessarily understand the CS stuff. Right, right. Maybe. It's a little low level for them, frankly, you know. Um, okay, let's see. Um, hold on. I just thought of something, and if I don't write it down, it will be gone forever. Okay. Yeah, the other thing, the other person that's the target for it is you, the one who built it. You build it because later on you're going to forget what you were thinking, and you write it. You do it a lot for yourself. Yeah. There you go, Mike. That's exactly where I was. I didn't see your comment, but that's where I was going. You in 8 months. You in 3 months. You know, just try, what was I thinking? Made sense when I was immersed. Then you lose that moment. Okay. Fowler says this is simple. Agree or disagree? Let me do a survey. Time for a survey. Get everybody awake. I'm going to go survey. Um, I agree with Fowler. That this is a simple UML class diagram. Yes or no? There's a survey question. And then, irrespective of whether you're voting yes or no on that, what's your rationale? What is it? Because I think that the first thing that tends to happen is you look at this and just go, whoa, you're kind of hit by a bunch of boxes, a bunch of words, a bunch of crap. Kevin said it's a little wordy, but I think the overall concept is simple. Yeah, no, and right now we're at 10 or 12 to nothing. And I'm gonna agree. I'm gonna vote yes. I think it is a simple UML class diagram. I have seen some very, very big, ugly, complex class diagrams that describe how the classes interact with each other. Understand that the more complex the interactions are that are exhibited in your class diagram, um, the more difficult it is to try to understand it, make some sense out of it, which is your kind of core job. So sometimes you have to move up, include more, but reduce the level of detail. Like these class diagrams talk to each other, but don't get into what they're made of. Give me a name and that's it, for example. So, because sometimes I could do order, not include all of this, you know, or only include the information I need, indicate that there's more that's not there, and just show the relationships between them without the detail inside of them. Um, Riley said it's only using some of the basic UML notation, none of the more complicated aspects. Also true. True in that respect of the feature set. That's right, Riley. That's really good. 2 points for Hufflepuff. Walter, if the class diagram gets too complex, it seems the actual code becomes pretty fragile. Please explain, Walter. I don't disagree with that at all. I think it's an astute observation. Um, but curious, what you mean. Like, why does that naturally follow that if the class diagram gets too complex, then the code becomes pretty fragile? If you wouldn't mind, Walter, throwing that in there. Um, yeah, I'm not a fan of putting too much detail into one diagram, just because it just gets harder to make sense out of it and maintain it. It's supposed to assist you, and you can write more. It's like having when you're trying to write and having a long sentence. Sometimes it's just one, it's 2 or 3 sentences dying to be broken out, right? Um, but let's see, what else? I think that also it's extra cluttered because all these we talked about, association, multiplicity, constraint, role name, these are all features. And so there's more words than it would otherwise have, if you weren't trying to teach UML. Um, Let me see, Alex, the longer the chain, the more opportunity for weak links? Yeah, yeah. Well, here's the interesting thing. Sometimes a diagram is too complex because you've thrown too much into the diagram, but the system itself needs to be that level of complexity, right? So in other words, sometimes it's too complex because the system itself is too complex, which is what Walter is talking about, right? That the more complex, in other words, you can have UML that accurately reflects a complex system, right? Complex system and complex UML to describe it. If that's the case, I would do high level reducing detail, then drill down like just a class diagram just for a class. Then when I use that class to talk about how somebody else descends from or whatever, I grab the information that I need to be reflected. If I throw everything, in the kitchen sink in on every diagram, everything gets too complex and you can't handle that cognitively. There's too much to sort of abstract out of it. So I think that's right. So Walter, I think you're speaking of where the UML is accurately reflecting the complexity of the system itself, right? And I think Alex, you're doing the same thing. And there's a separate issue, which is the level of UML description you bring to bear. So let's say that the design is correct, whatever that is. Einstein is supposed to have said, like everything that gets attributed, right? I don't know. But Einstein supposedly said that all systems should be, I think it was Einstein, I could be wrong, that a system should be as simple as possible, but no simpler. I love the quote. I love the quote, right? As simple as possible. It shouldn't be simple. Was that Einstein? Um, it should be, it shouldn't be simpler than it is possible. I just love that. And what you're trying to do is find, I mean, when you think about the big thing he came up with was E equals MC squared. Everybody knows this equation. Some people even know what it stands for, and nobody really knows why that somehow enabled the atomic bomb, or why that, what that really unleashed to know that simple thing. But out of in every complex system, there is a relatively simple system dying to come out, waiting to be, reduced down to. Okay. Walter, yeah, Dr. K said it, but Dr. E also said it, I think, earlier than me. That's probably where I got it. Okay. So remember when we talked about the orders of ignorance? There's a principle. So the orders of ignorance, remember that when you have a framework, it enables you to ask certain questions. Remember that? So, once you have a framework, you can ask certain questions. Well, this is a framework. The framework encourages you to ask certain questions. And one of the ones, didn't want to blow you off, Canute, um, but you said shows a high degree of coupling. You got 3 agrees on that, right? Well, let's go look, right? You see a class diagram and it should invite you to ask the question, well, how's the cohesion and how's the coupling? Because those are issues that pertain to the interaction of objects, right? And if I have to know too much about you, then that's a problem. Um, so, yeah, I don't know if this is high coupling or not. Um, By the way, we do have some like employee and product that are abstracted away. There's more to that object than that, and we have abstracted that away to be more simple. Um, so tell me, Canute, and those that agreed with the illustrious Canute, what it is about it that leads you to feel like it's high coupling. And I'm just, I mean, I didn't obviously like study this in advance to make, to try to answer that question. Um, Some of the objects, I imagine that money is a class, string is a class, Boolean might be a class, depending on the language. Um, Knut says if it's overly complex, that leads to many dependencies with other classes implying high coupling. Okay, fair enough. We did say that we didn't think this was a very complex UML diagram. So now what? Now what do you make of that? What say? The other thing too, let me be fair to Martin. He's trying to drop a bunch of features so that you can identify multiplicity, which says an order can have more than, one or more. No, sorry. An order can have only one customer. A customer, that star on the multiplicity, can have more than one orders, and that's an association. Constraints, something that's sort of a kind of a documentation. Generalization and specialization, which, by the way, there is a very compelling school of thought that most of the time, if not all of the time, that specialization and generalization is a bad idea and that it's better to use composition. There is a very, very strong school of thought. I tend to subscribe to that school of thought in part because I guess I always felt like, I don't know, specialization always just seemed kind of cutesy to me. But I never really thought of, it led to a thing that they sometimes referred to as the yo-yo problem, right? For example, you're looking at code, and the code has a method call into some object. You look in the spec for that object, and that method call is not there. Why? That doesn't seem possible, does it? Why is that method call not there? Oh, because this object inherited from a parent class. Then you go up to the parent class, and you're looking for the method there, which is maybe defined and then just kind of brought on down, right? No, it's not there either. Why? Well, because the parent class was a specialization of another parent class. So you wind up going up the chain just to try to find the definition of a method. So you know how to even just call it. Then you're bopping back down to use it. Then you're bopping back up to understand something, and they sometimes refer to that as the yo-yo problem with object-oriented stuff. Object-oriented design, code maintenance, where you're dependent upon when you're using a lot of generalization and specialization. Yet that was one of the big touted things, but it's really almost better to just say, look, this thing has one of these, one of these, one of these, and it's all right there, kind of explicit. But your mileage may vary on that. You get, feel free to disagree with me. But remember the orders of ignorance, right? Remember that third order ignorance, you don't have a framework. Well, UML gives you a framework to ask questions like, what should I put in my design? I don't know, read Fowler. Maybe you should think about having attributes, operations, role names, multiplicity, association. Maybe you should, what are these? Every one of these is a question to ask. What is it? How does it get used? Oh, now when I'm doing my own design, I can think about how do I do that from a design perspective, right? And then there's Sapir-Whorf. Have we talked about Sapir-Whorf? Sapir-Whorf, the Sapir-Whorf hypothesis, so kind of attributed to Benjamin Whorf and Edward Sapir. Sapir was a linguistics professor. Whorf was his student, grad student. And the idea was that our language and our thoughts are very, very intertwined. There are soft forms of Sapir-Whorf, and there are sort of hard forms, okay, of Sapir-Whorf. The softer forms say that language influences us. The harder forms say without the language, you can't even think the thought. I think the most, yeah. And then Benjamin Whorf later went on to become, right, an officer on the Star Trek Enterprise, on the Starship Enterprise. Yeah, that really was his name, Walter. Benjamin Whorf. He did really, really cool stuff. I read a bunch of his stuff about the linguistics of Mesoamerica, kind of Central America, Mexico, that whole what they call Mesoamerica, and the language. He was probably the world's foremost authority on Mayan language, written and otherwise, and did a lot of really, really cool. There's some very, very fascinating implications, right? Um, languages, for example, that have no future tense. How do you plan when language has no future tense, right? Language that doesn't allow you to count, over like two, and then it turns into many, and what that does to, your ability, for example, to trade and to sort of, uh, it affects things, right? So language affects things. I'm not a subscriber to the hardest forms, to the stiffest forms of Sapir-Whorf, because I think that language gets created because an idea exists first, and you don't have a word to attach to the idea, so you make a new word up. I think as kids we do it all the time, right? Because you're developing language, and kids will, you know, come up with words, phrases, expressions, maybe borrowed or cobbled together from other things, but they experience a phenomenon, and and sometimes it's really funny, right? When kids will say words and we think it's super cute, right? Um, yeah, Landon said, people who grow up with languages that have fewer words for colors have a harder time distinguishing the colors that don't have words for them, right? There's also the famous, now this one, by the way, I have a book which debunks this theory, but it was referred to as, man, what's it called? The Great Eskimo Vocabulary Hoax. The idea was that Eskimos have more words for snow because they live in that world, right? And that's climate environment. It kind of stands to reason. The challenge is that we also have, like, they'll be like, Eskimos have like 20 words for snow. Well, we kind of, we sort of do in English as well. The language of our class is English. Um, right? We have snow, sleet, hail, slush, flurries, snow showers, you know what I mean, freezing rain. There's a bunch of things phenomenologically, but the principle is still sort of there, which is, and put it another way, sometimes you guys, not you guys, fluffy eyes, um, sometimes you will say, I've heard it from my students in the various schools I've taught at, and I don't know if I've heard it from you guys this semester, but it goes like this: I've never used calculus in my entire life. Once I had it, okay, that is not true. Maybe you never solved a double integral across polar coordinates. Fine, you know. Um, nice. Thanks, Walter. um, no, you with me? You dig what I'm trying to say? Um, because the point is that when you have had calculus, you think analytically at a deeper level. It trains you to think analytically at a deeper level. When you have algebra, it trains you to think conceptually, how to manipulate ideas and concepts when you don't just have a hard value. It's one thing to say 5 plus 5 is 10, but what about the relationship 2x? So if I drop, you know, a 5 into there, I get 10. But if I drop a 7 into there, I get 14, right? That is an algebraic concept, and it allows us to kind of work and manage and manipulate our way, around the world in which we live. Algebra does that. Trig does that. Stats does that. Calculus does that. All of these, computer science does that. Predicate logic does that. All that theory crap that is easy to hate, Turing machines and finite state automata and all that crap, So Seth, no, you've used calculus. Seth, you have used calculus. You just said exactly the opposite of the point I was making. There are principles of calculus, right? It doesn't matter if you remember calculus. It doesn't matter. If you got through it, it changed you, and you use it. Y equals mx plus b, man, that's the equation of a line, if my memory serves me. But no, but you don't use that. But I'm just saying, think about, just think about principles. We're on a bit of a tangent, but far be it for me to ever come back from a tangent. Think about principles in calculus. Okay? What if somebody says, let's say somebody comes, you remember the notion of trying to compute the area under a curve, right? And you can do the area under the curve as a very coarse grained, let me see if I can draw you a picture. Okay. So there's a curve, right? And one way to do this is I'm doing an amazing bit of artwork here. I could kind of talk about this thing with 6 points of reference, right? Now, what if I took it even less granular and I only measured this guy right there? Well, which of these is more accurate representation of the curve, right? Now, if I this is a concept that comes from calculus, right? Then I do this one, okay? Okay, you understand that there are people living out there, dwelling among us, maybe in this class, who don't understand the difference between this, and this. What impact does it have? Do you understand the difference between continuous data versus discrete? Continuous versus discrete systems comes from calculus. Do you understand the limit of the function? What happens, with the limit of the function in a given societal moment as n approaches stupid, right? That's a calculus idea. It trains your mind to think more concretely, gives you language from which to tease things apart. Stats is the same way. I remember sitting in a stats class, refreshing on stats, which I love stats. I tend to forget the details, like, oh yeah, what do they call it? I tend to forget stuff. But the idea, so I remember sitting in a stats class when I was on faculty at the Y, and I remember the first day, the professor, who's a friend of mine on faculty, and he said, the purpose of this class is to train you to read a newspaper. Right? The purpose is not for you to tell me what the, what do you call it? Right, to tell me what the, I'm totally blanking. It's the medication probably. Now, what do you call it? Standard deviation. It's one thing to say, this is all about. So one day you're going to be at the grocery store and you're going to be like, I really need to know what the standard deviation is of something. But the concept of standard deviations, even if you never remember where the idea came from, settles into your head and alters. It gives you a greater ability to tease the world apart. It does train your brain. So I'm just calling you out, Seth. You're the one that started that. And it doesn't matter if you remember it. And Landon said, I feel like people who say they never used it might have missed the point. No, Landon, I would say absolutely missed the point. Absolutely missed the point. There are people, one of the things I love about, take machine learning classes. Learn about things like local optimums. People get trapped in a local optimum. There's there's principles of life that flow from things like machine learning, overfitting the data, right? Overfitting the data. You can take any data set, torture the data until it confesses to something. You can do that. And people do that all the time, you know, about all the current societal issues. Just take COVID, take masks. People are just idiots, you know. People are like, well, I know somebody who wore a mask every day and he caught COVID. Right. You don't understand stats, do you? You really don't understand statistics. You don't understand probabilities at an innate level. I don't remember if you don't care if you understand and remember the equations, you know, but people who don't understand, you see the most illogical and horrific memes floating out there because people don't have an ability to think analytically, and that's what all that stuff is training them to do. Okay, I'm going to roll back through. Right, yeah. So Canute said, I've used the logic and principles of calc, not the actual math. Right, same here. Same. Occasionally there's something, right? Um, every time you use delta something, you're using the language of calculus. That's right, Riley. Um, Anthony said a lot of calculus has to do with rate of change. Yep. Walter, continuous and discrete memories of 2810. Thank you very much. William remembers the 2810 test of mine that beat the discrete versus analog into your brain. But to your blessing, right, William? I trust that you're happy about that. Jiggly, speaking of stats, if you haven't taken ECE 3710, Stats 2050 is a sub. Don't know what to expect from the class. Okay, thank you. Lance said, I can't remember the books I've read any more than the meals I've eaten, even so they've made me. Ralph Waldo Emerson, very nice. I like that a lot. You know, I love it when, like when when I was talking about, the Einstein quote and someone's like, I heard that from Dr. K. Well, I heard it from somewhere. I couldn't remember. But the principle settles in and becomes part of your repertoire. And I'm just saying, when you've gone through UML, bringing this back, look at that smooth segue. When you have gone through UML and then you don't ever remember it and you're like, I never used UML or I never used those design patterns, you're still being trained to think about ways of kind of managing the world, managing, the complexities of the world. Walter, my grandfather smoked his whole life and never got cancer. He never even coughed. Exactly. Therefore, it's safe for everybody. Stats says it's true. Gunnar said, using the logic and principles of calculus is using calculus. Math is just a language to express that logic. Yeah. And some of those are very, very small. So, for example, UML teaches you the principles of object-oriented design. That's what I'm getting at. So these diagrams that you're never going to remember and these particular things you're never going to remember, you'll still see things. Kevin, welcome to the post-truth era. Because people are idiots. 305G, we've been talking about logical fallacies, right? Ways of exploring the world around us. Yeah, I mean, man. It's horrific. Just the world out there the logic is just so bad. So bad. Anyway, then try to have a reasonable, family discussion at Thanksgiving. That's not going to end well. Okay. Point is, Sapir-Whorf said, if you don't have the language, you struggle to articulate the concept. And the language, when you teach somebody the language and you teach them the concept, you basically expand their ability to think. I believe it's true. I've had discussions with people where you're like, hey, how was teenagers do this sometimes. Some of you have been not that long since you were teenagers, but you're just like, hey, how was your day? Good. Well, now, granted, sometimes teenagers just have attitude and it's masquerading as bad communication. But, you're just like, so what happened? It was good, okay? What do you want? you know. But and that might just be bad attitude. But I've also just talked to people, older people who don't have a bad attitude, where you're just like, like I was out on the river and man, the walleyes were biting. Man, that was a good day. So what happens when you're fishing for what's life like when you're fishing for walleye? Oh, it's just the best. It's the best day. What about it? It's just the best. I mean, that might all be true, but can you tease it apart? Is your day is your day a discrete function with one data point called the best, or is it a continuous function that moves from morning to evening based upon what the mosquitoes are doing, what the weather's doing, what the river is doing, what the walleye are doing, right? What your hunger is looking like. There's do you see this multivariate analysis unfolding? Now, granted, maybe all you want is just to think that it was the best because you were on the river. A bad day on the golf course is better than a good day at work. Now, I certainly subscribe to that. But do you see what I'm trying to say? If you understand the notion of a continuous function and analog data and continuous data, we talked about this in 2810, and I say, what's the temperature in Lehigh, which is where I am, and you look it up you look it up. I'll do it right now. You look it up, and it says on my phone that it's 64 degrees, light rain forecasted. 64 degrees and drizzle. What's the temperature in Lehigh? What's the actual answer? No friggin' idea. Loosely centered around 64 degrees, give or take, depending on at least 100 different things. Not the least of which is location and altitude. How high up? How far spread? What are you close to? What are you not close to? You know what I mean? When you don't understand calculus, you just think that the temperature in Lehigh is 64 degrees because that's all you know, because that's all you were told. And the entire city of Lehigh is reduced to a single data point because that's the way it was discretized for you and you can't conceptualize. Then somebody comes at you and says, whatever. And you buy it because you don't have any way to refute it because you don't possess the skills. Calculus, trig, UML, they all provide you, teach you physics, whatever. They're just ways of providing for you skills that you can use. Okay, enough of that speech. It's a good speech. I like that speech. That's right, William. The vertical jump test, right? How tall are you? Yep. How tall are you? Nobody knows. Not with any precision, but good enough. All right. So these are the things. We got name, properties, operations, which are the key ideas in an object-oriented paradigm. Properties, let me see. Think of the properties as just the fields in a class. Data declarations, data that's encapsulated and managed, okay? And we're going to talk about attributes and associations, ways of articulating these attributes. Okay. Sorry, I mean these features, okay? So attributes and associations. These are attributes where you've got built into the object, these things, that's type. We're going to break that down a little bit more. Okay, this is the format for a line of text in the class diagram box. Okay, there's visibility. Let me find my mouse. There we go. There's visibility, which is this plus. We're going to walk through this. Name, type, multiplicity. Okay, so visibility is this guy here, plus for public, minus for private. And by the way, just so everybody has permission to like dial out, I'm never going to ask you to cough up this kind of crap on an exam, okay? I'm not going to ask you to do it. When and if you need it, you look it up. But having passed through your head, if you just are awake and engaged, it'll benefit you. If you're gaming the whole thing by logging in and tuning out, you know, you log in and then you jump on Seinfeld for 3 episodes, then whatever, you get, you know, you lose out. Your career will pay you. So, okay, Mr. Seeds just overfitted the data to use a machine learning idea. So there's no final. No, if there's a final, it will look a lot like the midterm. It's not going to ask you to remember stuff which might just get changed in the next rev of UML. Okay. All right. That's the name. This, by the way, this example is, I don't like this. This is bad pedagogy by Martin Fowler. Don't call this guy name when name is used there. This is not the same. This is the name of this string. It's called name. Here we're saying there's a visibility, there's the name of the data object or the data item, and this is just really bad because it's confusing, and it shouldn't be. Okay, so it doesn't have to be name. It can be like last name or full name or something, but it is the name. This is the only mandatory field. You have to put a type, which tells you what kind of object can be put there. It's like the type of a field in the code. Okay. Multiplicity says how many objects can fill the property, which we're going to get into a little bit later. And then it sets the value for a newly created object. Okay. So if there's no, it's a little bit like, it's kind of like a constructor, like a default value in a constructor. Okay. And then you can put, you know, additional properties. So, for example, that says read only. It might say clients may not modify the property. It can say anything you want. That's a string that just goes there. Okay. So that's this one down here. Did we do that one? No, but it's like this one here. If we look at here in the heart, so this is just walking through, you know, like a textual example. Here it is in practice. There's the visibility. These are all public. There is the various names, date received as prepaid line items. There's the type, date Boolean order line. Multiplicity, how many there can be. Multiplicity is one of the ones that kind of sneaks up on you. You don't really see that one coming. But when you're building systems, you know, you can have a limitless number, right, from 1 to n. You could say there could be none or there can be one. You know, these are important from a design perspective, right? And then right here, there's no default property string. Sorry. Oh, that was a sneeze. That's bad. Once you sneeze, then it's going, man. Then it's going. Whew. Thank you, Seeds. No, what I meant to say, that's a default value. There are none. And then that's a property string, right? Which just tells you that this order line is ordered. And again, okay, what does that mean? Is it an alphabetical order, or does that mean it's been ordered? That's bad. Oh, it's the beginning of the end. You know it's the beginning of the end, right? Okay. So these are the attributes inside the properties, okay? These are associations, which are the ways in which these objects deal with each other, okay? For example, an order can have 0 or 1 date. A date can be associated with any number of orders. There's a method called date received, which is called from order to date. It's a public method. We've got sources and targets because of the arrows. Okay, source, target, source, target. Okay, and this is breaking the other one down. Okay, oh man. Hang on a second. I have paper towels. Who needs tissues? How are we doing? We got 10 minutes. How are we doing on slides? Yeah, we're on 31. We're about halfway done. Just trying to see whether I can hold up. Oh, I'm so sorry. Okay, associations. Yeah, so the association, notice how here we have the notion of an order, which is this guy here. And the order is made up of some dates, which is the date right there. Order line, a Boolean is prepaid. So it's another way of sort of representing the idea. Now, one of the interesting questions is sort of like, what's the difference, right? Which do you prefer and why? Your mileage may vary on this one. I tend to feel like when I see this guy here, I tend to feel like, okay, that is a description of this guy, but it feels like more like I've got a date object that I build a date object. I build an order line object. It's a kind of an aggregation. It's composition, right? But really, that's all this is saying. It has a date. It has a Boolean. It has an order line. These guys can be objects. They can be built-in data types. And there's not like one right or wrong. But this, to me, this guy does feel like it's a lot more explicit about, the notion of composition, where this one looks a lot more like you built a structure. It looks a little more traditional. This one's also easier to just document than this one. This one's a lot more picture. It's more picturesque. Okay. Let's talk about multiplicity. They were historically called cardinality constraints. I like cardinality better because that's what I grew up with. But anyway, it's just a range of how many of a given thing can be used. So here is multiplicity. Okay, the 0 to 1 goes there, the 1 goes there, and there. This can be any. Yeah. Okay. All right, let me keep going. So there's a range of values. There's the notion of just 0 or more. They are unidirectional because there's an arrowhead. Okay. There's also bidirectional associations. People have cars, cars have owners. Person can own 0 or more cars. A car can have 0 or 1 owners in this system. There's a cyclic idea that if you start with a person, you can find their car. Once you have a car, you can find its owner, so that you can, use that information. And this approach, so using a noun phrase, you understand you can use like a verb expression like is owner of, or a person owns car. That would be using a verb phrase. Person is the owner of a car. To me, if you're going to be bidirectional, you should have like owns and is owned by, car is owned by person, person owns car. Or you could define this thing and call it like ownership and put it in the middle. And then just understand that people own cars and cars are owned by people, right? So I don't like this as an example. I think it's a little clunky. And all I'm looking for, remember all the things we've talked about, design, good design, bad design? If I look at it and I see everything you want me to know about it, and it's really, really painless and the barrier to entry is really quite low, then that's good. If not, if I have to stop and struggle, I'm going to look at why am I stopping and struggling, you know? So I don't like owner. I like ownership as, what is ownership? It's a noun. Yeah, that's the verb phrase, own, with a directional. Person owns car. To me, it's biased against trying to look back. Why can't you go is owned by? But it's bidirectional, so why not? Yeah, biggest weakness of the verb-based approach is that it's bidirectional relationship, and then you inherently impose a direction. I'd rather label the entire thing with the relationship, like ownership. You know. Yeah, so the bottom line is to add a label only if when you do it, it adds clarity. And in my opinion, putting something like has or is related to or is associated with or something like that is worse than nothing. It's like adding comments that just tell you what the line of code does when you can clearly see what the line of code does. It's just clutter. Doesn't add anything. So this one might be best with just person, car. Unless, you understand that people can drive different cars, they can rent different cars, they can steal cars, right? I'm only talking about ownership. Okay. Let's see. How are we doing? Time. We got just a few minutes. I stopped sneezing, thank goodness. Man. Well, we're getting close to. If we don't wrap up, which we probably won't, we'll get to the end tomorrow, Wednesday. I mean, we have 4 more weeks, including this one. Quattro weeks. Count them on one hand. Okay, these are operations. These are like the methods, right? So there's a visibility. There's a name, parameter list, return type, property string. So there's our visibility. There's a name. It's the only mandatory field. There's a parameter list. There's a return type and any properties. Properties are meant to, clarify or articulate ideas. So let's go here. The idea here is fill in only what you need to communicate your design. Okay. Notice that down here we've got dispatch closed just by themselves. Here we go bill for month with an integer. Here we go with a return of string. You communicate what you need to be effective. Somewhere it has to be there, right? What you're intending to do. That would have been better if it had busted out some arrows, but I guess I didn't do that. Generalization is this guy. Where are we at? Right over there. Basically, it's inheritance. Generalization and specialization. You've been through this, right? Yeah, and I'm not a fan. Some people live by it, but I'm not a fan. Let me see. How are we doing on time? 3:43. Yeah, so the idea here with when you use generalization, we get into the Liskov substitution principle, which you should have covered in your Skater Chick book. But the idea is that in this case, I've got customer as an object, and I've got corporate customer and personal customer that both descend from customer. Okay? I should be able to, if I'm doing this thing right, the Liskov substitution principle, who was that named after? Was it Barbara Liskov? Man, I hope so. I hope I'm right on that. If someone wants to look that up, I can't remember. But the idea would be, if I have an object called customer that I can do things with, then I should be able to use corporate called customer in exactly the same way and personal customer in exactly the same way. It's a form of modularity. I'm not like specializing and then corrupting stuff in a way that it doesn't work. Okay? So here's some formal definitions, which I'm not going to get in, but the last one I like better. Objects of a superclass must be replaceable with objects of its subclasses without breaking the application. Okay? Or in other words, if it looks like a duck, quacks like a duck, but needs batteries, you probably have the wrong abstraction. Okay? Like one of these, if you're like, yeah, it walks, it quacks, it looks like a duck, it quacks like a duck, and you break it because I can't just use it, I can't use them interchangeably. And here's the practical implications for the last minute. Actually, let's do this because we're out of time, and I just know I'm going to have another sneezy fit coming upon me. I've got right now literally less than 10 slides. We'll come back on Liskov next time. Let's do that. And then we can just wrap up right now. That's it. Let's wrap it. We're over time. I'm tired, sick and tired, allergic and tired. Don't forget to do the roll. Don't forget to sign attendance. Yep.
Do you still want to do any testing with your audio settings or anything?